Hello everyone, welcome to today's live session. Today we are going to talk about a very important topic and it's a Docker. And before going to Docker, let me tell you that architecture evolutions from 1992 modern containerization. If you are a DevOps engineer, cloud engineer or preparing for interviews, this session will give you clear conceptual understanding. So today we will cover what was one tier architecture, why monolithic architecture became a problem, why microservices were introduced, virtualization versus containerizations, imperative versus declarative automations. Okay, and if I'll get time, I'll go more, more, and more. Okay, so yeah, so let's get started. If I talk about one tier architecture, that is 1990. So let's go back to 1990, and at that time, applications were very simple. Okay, applications were very simple. One tier architecture. Okay, so at that time, applications were very simple. Applications were very simple. I can say front end, back end, plus database. Okay, yeah, front end, back end, plus database. Everything was inside a single code base. If I'll take an example, so desktop applications like Microsoft Office. So everything ran on one machine. Okay, designed for around 1000 users. So let me tell you the problems. Okay, here. So problems, I can say no scalability, no scalability, not designed for internet level traffic, not designed for internet level traffic, single point of failure, single point of failure. So these are the problems. If the system crashes, entire application goes down. Okay. So now monolithic three-tier architectures come in pictures in 2004. 2004 three-tier architecture, monolithic. So after 2004, web applications become popular. So then came three-tier architecture. that is front end, back end, and database. Okay, front end, back end, and database. So most of applications like front end we can write in React, Angular, Next.js. Backend we can write in Java, Python, .NET, and for database we have MySQL, SQL Server, and many of many of things. Okay, so but everything was tightly coupled. Okay, so if backend fails, entire system down. If database has issue, whole application affected. So like that it happens earlier. So we have also a problem here in monolithic. Okay, that hard to scale, hard to scale specific component. Then high restart time, high restart time, risky deployments. We have a problem as a problem, risky deployments. Entire app must be redeployed even for small change. For small changes. Okay, so these are the problems we are facing in monolithic three-tier architecture. So imagine you change only the login feature, but you must redeploy the entire applications. Okay, so it was happening there. But in 2011, microservices architecture came in picture. Microservices architecture. Okay, so then companies realized large monolithic applications were hard to manage. So microservices architect was introduced. Now we have cart is a separate service, orders separate, accounts separate, wish list separate. So each service run on its own VM. So what are the advantage of that? Let me I'll write here. Okay, so we have different services. So what are the advantage for this? We got Advantage: independent deployment, independent deployments. Okay, then independent scaling, scaling. We had advantage on this part. Okay, so but new problem appeared. Okay, but new problem appeared. Let me write as new problem, and that is memory wastage. Memory wastage. Okay, so each service allocated 2 GB or 4 GB RAM, even if it is if does not fully use it. Okay, means if we are giving one services to one VM, means if it is utilizing only some part of memory, so all memories are wasted, are in at standby position. Okay, and we have some other issues like VM restart takes minutes, so leads to downtime. So that time our application will get downtime. And if as user increase from 10,000 to 1 lakh, or from 1 lakh to 1 million and all, so number of VMs increase, infrastructure cost also increases, DevOps complexity also increases. So now we had come in picture the virtualization. I already spoke about this virtualization in previous video. Okay, virtualization. Okay, so for setting that virtualizations, we need a physical hardware of some GB RAM with some core CPU and all, and we have host operating system for that. Hypervisor we have. Okay, we have multiple virtual machines. So each virtual machines I already explained you here, that having guest operating system. Okay, middleware, and we have to give application code to them. Okay, so like that it happens in virtualization. So problem here is every VM has its own guest operating system. So if it having the guest operating system, means high memory consumption is there, slower boot time we have, inefficient hardware uses we can say here. So if you run 20 VMs, so you are running 20 operating system for them. You can see here this example, the virtual machine one. Okay, now containerization, the game changer we can say here. Okay, so then came containerization. So for setup, we have host operating system. Okay, Linux kernel. Okay, container engine, containers. Okay, so important difference here, you can say no guest operating system we are having here in containerization. Okay, so containers, whatever containers numbers we have, they are sharing their same Linux kernel. Okay, so we have some advantage of that containerization and all. So we have very lightweight, fast startup, we can say in seconds, better resource utilizations, minimal downtime, high scalability. Okay, so we can say containers are slim, fast, and very efficient. Okay, now in Linux we have a feature called control groups. Okay, so it allow us to limit CPU uses, limit memory uses, controlled resource allocation per container. Okay, so for example, if I'll say you can restrict a container to use only 512 MB RAM. Okay, like if I want to set a restriction for container A to use only 512 MB RAM, so we can do that. Okay, like that it is having. So if I'll talk about automation, that is imperative versus declarative and all. So we have, for imperative we have Azure CLI. For declarative we have Terraform, Bicep, ARM templates. Okay, so whatever you have desired, you can fulfill it with the help of this approach. Okay, whatever you needed. Okay, so you have to figure out how to reach that your desired state and all using your declarative approach or your imperative approach. But nowadays declarative approach is too much in demand, so you must know Terraform. I have other videos for Terraform, and I'm going to plan for Bicep as well as ARM template. Okay, so in future I'll take that, no issue. So when to use what? If you have small tasks, you can use Azure CLI. If you have large infrastructure, you can use Terraform. Okay. So at enterprise level, I can say declarative tools are very, very preferred here anywhere. Okay. So if uh, if I'll talk about containers, so in modern environment, you know, creating Docker file, build image, okay, deploy that image, then we need to version, okay, version update means deploying new images. Okay, so we should have simple, clean and version control rule for us, so that it came in picture that containers one and all. Okay, so I'm going to write some command. Already I given you, so let it practice and do the things. Okay, so now let's continue the practical example. Okay, so I have one software, that is Docker Engine. If you are in Linux, I already told you how to install, I think, Docker one. Yeah, for Linux, I already told you how to install Docker with the help of Docker.io. And for Windows, you have to go to download Docker Desktop. Okay, Docker Desktop for Windows. So you will get a download file according to your machine, and you can download Docker Desktop and install it in your Windows machine. So in Linux, you are not going to feel UI and all. Okay, everything you have to see in CLI mode only. Okay, and here you are getting UI feel of Docker. So let me start. Everything, whatever command you want to run for Docker, you need to uh, install and start your Docker engine. Okay, Docker engine is nothing but for Windows machine, that is Docker Desktop. Okay, so if I'll let me let me create today's date folder, so we can able to recognize when we had our previous session. Okay, so very long time I am coming, 13 022026. Now I'm going to run a command. Okay. So your VS Code should be in this condition only. Okay. This is the explorer. This is the configuration file you have to write here, and this is the terminal down one. Okay. And the right hand side is your chat GPT things there. Okay. Let me make it little bigger for you guys. Yeah. So now I'm running a command docker pull nginx. Docker pull nginx. Okay. So if I'll put enter, you will get an error. Okay. So I told you earlier that if you want to run any Docker command, you have to start your Docker engine. Okay. You have to run your Docker engine. So running Docker engine means starting your Docker desktop. Once the Docker desktop will start, my command will get run without any error. So this is the real feel of Docker desktop. We have UI user interface here of Docker desktop. Once you can see here starting the Docker engine like that it was saying. Okay. If you can see here, you have container option, you have images option, you have volumes options, you have Kubernetes option, you have build option. Like that you have also a Docker Hub option here. Like that you have options. Okay. Whatever image is there in your local, it will show here. Whatever the containers running or not running, it will be here only. Whatever the volumes you created, you can see here. Okay. So these three is very important while you are going through Docker. Okay. So while now I'm going to pull that Nginx one. Now I'll show you where it was showing. Docker. I'll put up arrow. Yeah. Docker pull Nginx. Now you can see without any error your command is running. Okay. So this downloads the Nginx image from Docker Hub. I already showed you that Docker Hub and all. Let me again show you Docker Hub. Docker Hub means where you can keep your images. Okay. It kind of library. Okay. Library in what we have lots of books. Okay. So that it we call library. But if we have so many images and we have a place that is called Docker Hub. Okay. You can see lots of images here. Okay. These are all are the images. Okay. So now you had seen that how to pull that Docker pull. Now I'll show you Docker desktop here. Let me click on images. Now you can see here Nginx image came to my local my system with the latest tag with image ID, and when it was created you can see 8 days ago, and the size of that image, particular image. Okay, 237.06 MB. Now let's run a container. Now let's run a container. Docker run Docker run nginx. So nginx is now running. Okay. So but if you run like this, you will notice something here. Okay. that the container runs, but you cannot access in the browser. Okay, so why? If we have VM, so we need to expose the particular port. Okay, if it is in VM, we need to expose the particular port, but we are running in local. Let me see whether it is coming for me in localhost or not. Okay, so it is not coming in her local host. Okay, so let me map that host and our PC with the container port host. So, and if you are not writing any, now you can see your console is busy right now here. If you are not putting anything like minus D and all, so I'll show you that once I'll put minus D for detach mode. Okay, let me first put control plus C so that it will get cancelled. Ah, let me show you again the Docker engine. Yeah, now again you can see here. Now I'll click on container. Now you can see that one container is running for me, that is Nginx. And you can see here that some name is given by default, and that name is recursing underscore Alice. Okay, so if you are not providing any name, means it will automatically named by this Docker engine and all. And once you run the container, you will get a container ID. Okay, and from which image it is running, it will show you here. And what is the age of that particular container, you can see here. Okay, the 51 second ago, like that you can you can control the container images from here also. Okay, if I'll put here stop, it will get stop. Okay, if again I'll run here, it will again run, like that it happens. Okay, for image also we have here. Okay guys, so now let me write, let me cancel it first. Control plus C, I cancel it. Okay, now I'll run again. Now you can see here Docker desktop, what happens here for container. Now your container is in stop condition. I have already given you so many commands on previous uh, session. Okay, if I'll show you here, Docker build, Docker run, Docker push. Okay, like that. So if you want to see the images, okay, you have Docker images. If you write Docker images, you can see how many images you have. You have three images. Okay, if you have Linux machines, you can see like this only. But if you are in Windows machine, you can use either that one or this one. If I'll come to image, you can see here that three images is available. Okay, that is this one, this one, this one. And if you will compare with this CLI, okay, you can see here the same three images. Now Docker PS, Docker PS. Docker PS is the command from which you can see how many containers in running condition. Okay, how many containers are in running condition. Now we don't have any container which is running right now. Okay. Again, we have next version of command, that is docker ps minus a. Docker ps minus a. That will list you all the containers means all the containers means all containers which is in rest position or in stop condition, or which one is in running condition. Okay, both you can see here, but for the docker ps you can see only running condition. Okay, let me again, I'll show you with this command docker run nginx. If I'll run this, okay, and let me open new terminal. This console is busy right now. Okay, if you're not using minus d here, that is detached mode, I'll tell you in next command. So if you're not using that minus d, means your console will get busy. Okay, so for that I'll take new PowerShell command prompt. Okay, now I'll write here docker ps. Now you can see the same thing, container id, image name. Okay, names, when it is created, and what is the status, that is up. Okay, now if I'll say here control c, now I stop my container. Now again I'll run this command. Now you can see no container is running. Okay, so this is the difference. You will get this command in your finger once you do practice, more practice and all. Okay, so I am deleting this terminal. Okay, now come to that next command, that is docker run minus d. Minus d means minus d means run in detached mode, means in background. Okay, minus p means port mapping. Okay, so I am doing port mapping with 8080 colon 80. Okay, the first is your port with means your virtual machines port or your computer port, and that is the next 80 is your container port, what you are going to make it. So minus p means port mapping. We are going to do the port mapping of container port with our machine port. Machines should be your virtual machines or your VM or your own PC. Okay, now I have to give image name. Okay, you can give image name, you can give also the name also. Okay, this particular container. Now I'll write nginx. So now you can see. Okay, now you can see one id generated. Now if you will do here docker ps, so you can see one container is running. Okay, and we have port forwarding from 80 to 8080. Now if I'll run localhost, we can see nginx. Now you can see nginx is running on localhost 8080. Okay, so this is the power of docker. So if you will browse it, you can see nginx in your local machine or in your VM. So I'll already told you that command docker ps minus a. Okay, if you want to stop container through command, so you have docker stop with container ID. Docker stop with container ID. So you can see the Docker is stop. So I'll show you Docker PS. Okay. If you want to remove container, now it will show you with this ID. You can see with Docker PS minus A. Docker PS minus A. So you can see here 2 minutes ago this one. Okay, this one is already there. So if you want to remove, you can remove by Docker rm and your container ID. So this will get removed from your list. So let me put this enter. Now you can again do Docker ps minus a. Now you can see no container is there with that ID, this ID. Okay. So if you want to delete more container, Docker rm, then you have to select this ID space. You have to give container ID again, and if you want to delete this also, you can give with space. Let me try to put enter. Now you can see three containers which is in a stop condition is also deleted right now. Okay, so let me see again Docker ps minus a. Now you can see all container is gone. Now if I want to again delete all the containers, Docker rm, again I'll do. You have to do practice like this. Okay, if you're not doing practice means you are not able to learn more and more. Now I have not a single container in my list. Docker ps minus a, not a single container is here, not a container is running condition. Okay, both are empty. Now again I'm going to create a container, Docker. Now if you can see here, if I'll put refresh, it is gone. Let me again run a command, Docker run minus d minus p, Docker run minus d minus p 8080 colon 80. I'm giving right now the name dash dash name of my container. Okay, so I'm giving name as Surya. Okay, and at the end I have to give. You can give a name at first, last, not a problem. Okay, you have to give anywhere like d minus d. You can give anywhere. Minus p you can give at last also. Not last means at last you have to write your image. Before that writing your image you have to give that thing. Okay, now I'll write here image nginx. Now Docker ps minus a. If I'll do, okay, I'll do Docker ps only. Now you can see here id image. Okay, and name Surya, and this port forwarding one. Again if I'll come to here, nginx port, nginx image is there. If I'll click on container, one container is running. Now port is showing here. You can browse from here also. You can browse your nginx from here. You can see welcome to nginx pages. there in front of you. Okay, now you can stop image easily. Okay, now you can delete that easily. Okay, so I'll tell you that Docker file and all. Okay, like Docker file and all. So Docker file is a blueprint. Okay, Docker file is a blueprint. Example, if I'll tell you here, okay, if I'm writing here from, okay, from Nginx, means I am using Nginx image and copy, copy dot space, not space, dot, then you have to give the path. I'll show you once how to enter into container and how this path is there. User share Nginx HTML, Nginx HTML, and expose 80. Okay, so this is a blueprint, and we can say this is a Docker file. Okay, this is the basic of Docker file. If someone asks you that Docker file, how can we write? So this is the way we can write Docker file. Okay, so what this does? From from Nginx means what? We are using a base image. Okay, Nginx as a base image. Copy dot, and this one means whatever we have, copy our app files. Whatever the app files we have, we are copying all the things where in this path. Dot means current, and this is another one is the path where we are going to copying it. Expose 80 means we are exposing our port. Okay, so if we want to build, if we want to build custom image build, we can say we can build it our own image. Okay, so for building it, you have to write docker build -t, and you have to write any name. You have to write any name. Okay, I'll write here my custom image, my custom image Nginx, and you have to put dot. This dot you have to put, and this is mandatory. Okay, uh I need to give, I think, one space here, so that is the issue. Now I have given here one space. Now again I'll build it. Now you can see your custom image is built with the name of my custom image Nginx. Now let me show you in Docker. desktop, you can see my custom image nginx is built. Now this is your custom image. From this image you can run your nginx. Okay, let me delete this container from here. Okay, uh, first we need to stop, then we need to do delete. So make it practice like this only. Okay, now you don't have any container. Now let me refresh this. Now we don't have any container running right now. Now we have some command. Yeah, now in the place of this nginx, I'll put my own image. My own image means my custom image nginx. My custom image nginx. Let me try to create container from this image. Now you can see your image is your container is created and in running condition. Now you can see Surya image is again created container, sorry, and again we can browse it. Now you have your own image as a custom image, you can say. Okay, so this is the process how to write a Docker file, simple Docker file. Okay, so we have so now your own HTML app will run inside Nginx container and all. Okay, so for that you need volume and all. So we will go it later. Network, we can create network. Okay, so if container is not working, so we need to check logs and all. So we have command docker logs, docker inspect with container id, or we can go through container name. Okay, so these are very things we need to do. So that's all for the day, guys. Tomorrow or day after tomorrow or whenever I have time, again I'll come to you and make a very useful session for you guys in Docker. Okay, so thank you for the day and let's meet in our next video.